Can we build a circuit that generates a digital signal? Yes, we can, and that's what we're going to do in this lab. So our output, instead of going to an oscilloscope, our output's going to go into an LED. So you're going to see the light on, representing high or 5 volts, and the light will be off when our signal is 0 volts or low. To build our circuit, we are going to use a 555 timer 8-pin integrated circuit chip. Now, this is what the chip actually looks like, and it can actually function in several different modes. We're going to use it in what is called oscillator mode. It will produce our nice digital output where we will get 5 volts and 0 volts. And again, it'll be represented by an LED, which will be on, representing our 5 volts, and off, representing our 0 volts. Now, in order to get this thing working properly, we're going to need to connect our chip to a couple of resistors and to a capacitor. So this is a nice animation of what's going on with our 555 chip. So again, inside of the chip, we're not going to worry too much about how that works just yet, but inside of the chip, that's this gray area right here, and you can see that outside of the chip, let's talk about that. Outside of the chip, we have an output from this flip-flop. Again, we're gonna learn about JK flip-flops eventually, but we have the output running to this LED. Now, when you actually wire this, there is an LED right on your board there. You're gonna run it to a little LED light, actually right above the breadboard is how you're gonna run it. And you're also going to need a couple of resistors, resistor A, resistor B, and a capacitor. Now, remember, a capacitor is something that holds charge, and what's happening right here, I know it's going rather quickly, but you can see that as the capacitor is charging up, the light is on, and then at some point, this flip-flop is triggered and the light turns off, and then the cycle repeats itself again and again. So as the capacitor is charging up, the light's on. As the capacitor is discharging, you'll notice the light is off. Just stare at that for a moment. Convince yourself that that is in fact what is happening. And now actually you can imagine, what do you think would happen if we increase the size of the capacitor? If we make the capacitor bigger, I think you might imagine that it's going to take longer to fully charge up and longer to fully charge down. So that might increase the period of our square wave, of our digital wave. I think that makes sense. And you might also imagine that if we increase the size of our resistors, right, more resistance, that might also affect how long it takes the capacitor to charge up and to discharge. And probably the more resistor, the greater the resistance you have, the longer it will take. Well, that makes sense, right? If I have a really huge resistor, it's going to take longer for my capacitor to charge up because I'm getting less current. And the same thing with discharging the capacitor. And you'll see that that in fact will be the case when you actually build the circuit. This is another nice diagram of really what's going on here. So as it says in the diagram, while the capacitor is charging up, the output light is going to be on. And the capacitor is charging up by sending my power through resistor A and through resistor B. So obviously, if you increase the resistor A and resistor B and the capacitor, obviously that's going to increase the amount of time that your output is high. And actually, here's a nice little equation, and you're going to use this equation to calculate how much time our output is high, right? How much time the output is at 1, or how much time the light is on. Now, you don't have to memorize this equation. This is, of course, on your reference table. We're almost done, just one more slide after this. So this diagram is showing that the output will be low. In other words, the light will be off as the capacitor is discharging. Now the capacitor is going to discharge through resistor B. So obviously, if I increase the resistor B, it's going to take longer for the capacitor to discharge. And of course, if I have a bigger capacitor, it'll also take longer to discharge. That's why the amount of time low is based on, well, again, we have this funny constant in front, multiplied by resistor B and the capacitor. Again, you do not have to memorize these equations. They are right on your reference table. And finally, here are the equations once again. Again, the amount of, the period is going to be based on this equation. Again, you do not have to memorize any of these equations. They're right on your reference sheet. So this is the period Of course, frequency is the reciprocal of that, and then you have another equation for duty cycle. It's all going to be there, so you can easily do the calculations, and that should be enough to get started. Thanks for watching.